variables on both sides. The process that we're going to use here when I have variables on both sides of an equation is essentially the same exact thing that we were doing, except there's one step I'm going to insert into the middle. And that is step number 3, which is get the variables to one side. Other than that, though, they're the same exact steps that we've been doing. Number 1, we always start with distribute, if possible. After we distribute, we check for like terms and combine them if we have them. Then this is where we insert our step that is extra, the new step, which is get the variables to one side. And we are going to be doing this using, use addition and subtraction. After our variable is on one side, it should look like all of those other equations that we've been doing. So then we use our reverse GEMDAS, right? Starting with addition and subtraction and working our way backwards. So undo addition and subtraction, and then undo multiplication and division. Nothing too crazy here. Let's look at an example in letter A and see what we got. So in letter A, I see I have a K on the left side, a K on the right side. I go through my steps. Number 1, is there anything to distribute? No. Number 2, is there any like terms? Well, when I say like terms, I'm referring to like terms that are on, you can leave it on my desk if you're done. Like terms that are on the same side of the equal sign. So I look at the left side there, 7k plus 2. Are 7k and 2 like terms? No. I look on the right side, 4k and negative 10. Are those like terms? No. So there are no like terms to combine on the same side of the equal sign. So we move to step number 3, which is get the variable to one side. We're going to do this using addition and subtraction. It does not matter what side you decide to put it on. I usually try to avoid negative numbers if possible. But if you like moving your variable to the left side every single time, be my guest. This one, I'm going to pick the left side, and I will split it down the middle just like I always do. And I say, okay, I'm going to move 4k to the left using addition and subtraction. We're doing inverse operations. Is this 4k positive or negative? Positive. It's got the invisible plus sign in the front that we can't see. So to move it, I have to do the opposite, which is subtract. And what I do to one side, I do to the other. So they cancel out. And now I'm subtracting 7k minus 4k. Those are like terms. They have the same variable. 7k minus 4k is 3k. I subtract the coefficients, leave the variable the same. You can leave it on my desk. And everything else just drops down. From here, this should be familiar, right? Like we've done this a million times already. I go ahead and subtract 2 from both sides. I divide both sides by 3. I'm left with k equals negative 4. Any questions on that? Okay, let's see it happen again. In letter B, again, do I have anything to distribute? No. Do I have any like terms on the same side of the equal sign? No. So I move to step 3, which is to move my variables to one side. What side do we want to move them to? Doesn't matter. Somebody pick one. Let's move them to the right side. So to move the 3x to the right side, what do I have to do? Subtract 3x. Because again, here's my invisible plus sign that I can't see. To do the opposite is minus. I drop the 4 down. 5x minus 3x gives me 2x. Drop down the negative 10. Add 10 to both sides. And finish it off by dividing by 2. Questions? I'm going to skip letter C. Are we okay with that if I skip one? Let's look at D. What is my first step here in letter D? I heard somebody whisper it. Read. The parentheses. We have to distribute first. So I'm going to distribute 1/2. 1/2 of 16y is 8y. 1/2 of 8 is 4. I have to distribute the 2. 2 times y is 2y. 2 times negative 13 is negative 26. Do I have any like terms on the same side to combine? No. So I can move straight to moving those variables around. What side do we want to use this time?
Left.
Perfect. I see that invisible plus sign, so I'm thinking I subtract my 2y. I'm going to subtract 4, which gives me negative 30, and then divide both sides by 6. Y is negative 5. We feel like we got this? I'm not telling you anything new and crazy? Okay, one more. Well, I know there's more than one, but there's one more on this page. What's my first step here? Jay? Like terms. I have like terms on the left side and I have like terms on the right side. So on the left side, I see 3x and negative 6x. I can combine those together. What does that get me? Negative 3x. That 4 drops down. What are my like terms on the right side? Where are the like terms? Autumn? Negative 12 minus 14. So I can drop down the 2x. Negative 12 minus 14 gives me negative 26. And from here, what do I do next? Read? Okay, Reed says let's move it all to the left side. So subtract 2x from both sides. We're going to end up with a negative 5x, which I don't like, but it's not bad. We can still do it. I try to avoid negatives at all costs, if possible. From here, what am I looking at? Subtract 4 from both sides. So negative 5x equals negative 30. Divide both sides by negative 5. X equals positive 6. Sound good? Oh, yeah. All right, any questions on the front page? On the back page, there are 4 questions. Go ahead and give them a try. Share with those around you. Make sure you got the right answer, and then I will take volunteers for these 4 problems. Sarah's going to do one of them. Remember, you can zoom.
Is this right?
Yeah, you can zoom with your fingers if you need to zoom in. And the back is the eraser. Oops.
Imagine like a home wall with Scott in the wall. And you make like jump off a bridge. Are you doing that, Mama? Yeah. You jump off a bridge and like kind of land in like a water hole.
What are you yapping about? Who's got letter B? Yeah, that looks right. You can zoom with your fingers. The back is the eraser. Amazing. Who's got letter C?
This one right. That's right.
I think so. Oh, that looks right.
Okay.
What are we doing? Do I need to separate the group of you over here?
Huh?
What's going on?
Singing alphabets.
Do some problems?
I was thinking about it.
Yeah, I know. Perfect.
I don't know what
Who's
that
got
is.
the last
That's
one?
not an A, but
Yeah, it's an ugly number, but I like it.
is this right?
Yep.
Okay.
No,
What? So loud.
All right, great job.
Oh boy.
There we go. Beautiful. All right, any questions on these four? Fantastic. Let's look at our word problem. Then we're almost done. Home stretch. Remember, when we do these word problems, we need two things. We need to define the variable and write the equation before we start to solve. I haven't graded your quizzes, but I did see some of us were missing crucial steps, which means you don't get full credit. Letter A. You and some friends decide to go bowling 2 weekends in a row. The first weekend, you go to Alpine Lanes, where shoes cost $3 and each game costs $7. The second weekend, you go to Classic Lanes, where the shoes cost $5 and each game costs $6.50. After how many games would the cost be the same? When we define our variable, I'm looking at what don't I know, what am I trying to figure out? What's my variable here? What don't I know in this problem? Autumn. X is the number of games. I need to see that written down for these word problems. We can't just make up a variable and not define it. Then, two things are happening. We're going to Alpine Lanes one weekend. We're going to Classic Lanes the other weekend. So I'm going to have two different parts of my equation. Let's start with Alpine. I need to set up an equation that tells me how much it's going to cost for me to go bowl at Alpine. Let's look at that first part of my problem here. I'm going to highlight. The first weekend you go to Alpine, where shoes cost $3 and each game costs $7. How would I write that as part of an equation? How do I represent that in terms of math? How do I say it costs $3 to rent shoes and $7 per game? James? 7x, which is $7 per game, plus $3 for the shoe rental. Perfect. Then, we go to Classic Lanes. And at Classic Lanes, it says it costs $5 for the shoes and $6.50 per game. How would I write that part? Yeah. 650 times X, so $6.50 per number of games, plus $5. Now the question asks, after how many games would the cost be the same? So what do I want to be in the middle? An equal sign. Perfect. Can we solve this now? What am I going to do to solve? First step, can I distribute? Can I combine like terms? I don't think so. So first step is move everything to one side, right? Move my variable to one side. I'm going to subtract 650x, which gives me 0.5x plus 3 equals 5. Move the 3. 0.5x equals 2. Divide by 0.5. X equals 4. So what this is saying is, after 4 games, it's going to cost the same at Alpine and at Classic. They would cost the same after 4 games. That's part 1. Part 2 asks another question. Which bowling alley offers the best price for 5 games? How am I going to figure that out? Autumn. Yeah, I'm going to plug in 5 because 5 is number of games. X represents number of games. So if I want to know what the price is for 5 games, I'm just going to plug it in. Alpine is first. 7 times 5 plus 3, which is 35 plus 3, or $38. Classic is $650 times 5 plus 5, which I think $650 times 5, $32.50. So in total, $37.50. So clearly one is cheaper, right? Classic Lanes, $37.50. You're saving a whole 50 cents. Isn't that crazy? All right, any questions? Okay, here's your homework. Remember, you are going to do this. You're going to check it with me. You're going to check your answers on Classroom. Come back to me for your little stamp of approval. And then post on Classroom. 2, 3, 4, 5. All right, get to work. Let me know if you need any help. So, not pause.